Hi guys, welcome to this session of analytical questions asked in CBSE Class 10 board exam from Light Chapter. These questions requires a sound knowledge of the concepts. Analytical questions typically involve critical thinking and problem solving. A tip is to read such questions thoroughly, understand it completely, and then start solving. Let's recall concepts learnt in this chapter of light. Let's start with refractive index. The refractive index N of a medium is a dimensionless number. It describes how light propagates through that medium. It is defined as the ratio of the speed of light in a vacuum c to the speed of light in the medium v. N equals slash. Here, c is the speed of light in a vacuum, approximately 3 by 10 rays to 8 meters per second. V is the speed of light in the medium. Let's continue with refractive index and its meaning. V deduce. The above expression means that light travels slower in medium compared to air or vacuum by a factor n. For example, if the refractive index of glass is 3 by 2, it means that light travels slower in glass compared to air or vacuum by a factor of 3 by 2. Refractive index n greater than 1 means the medium is optically denser than a vacuum, and light travels slower in that medium. Let's recall absolute refractive index. The absolute refractive index of a medium is the ratio of the speed of light in a vacuum to the speed of light in that medium. Formula: N equals by, where c is the speed of light in a vacuum, and v is the speed of light in the medium. Refractive indices can vary depending on the nature of the medium and the circumstances under which light is passing through it. Here, the speed of light in medium is compared to the speed of light in vacuum. The relative refractive index is the ratio of the speed of light in one medium to the speed of light in another medium. It indicates how light will bend or change direction when transitioning between two different media. Formula: relative refractive index of medium 2 with respect to medium 1 is equal to by where V1, V2 are the speeds of light in media 1 and 2, respectively, or equal to 2 by N1, where N1 and N2 are the absolute refractive indices of media 1 and 2. Question 1 on refractive index. The refractive indices of glass and water with respect to air are 3 by 2 and 4 by 3 respectively. If speed of light in glass is 2 times 10 raised to 8 meters per second, find the speed of light in water. Here the refractive indices are absolute refractive indices. After reading the question, let's write the given values as given. Refractive index of glass, N equals 3 by 2. Refractive index of water, NW equals 4 by 3. Speed of light in glass, Vg is equal to 2 times 10 raised to 8 meters per second. We know the refractive index of glass is 9 mol. Now, to find the speed of light in water Vw, we use NW equals C slash VW, 2, from 1 and 2, and dividing equation 1 by equation 2 we have. Then simplifying and calculating the speed of light in water as VW is equal to 2.25 times 10 raised to 8 meters per second. Question 2. The image of an object formed by a lens is of magnification -1. If the distance between the object and its image is 60 centimeters, what is the focal length of the lens? I repeat, the image of an object formed by a lens is of magnification -1. If the distance between the object and its image is 60 centimeters, what is the focal length of the lens? Recall image formation cases in convex lens. The different cases of image formation of object at infinity, beyond 2f, at 2f, between 2f and f, at f, and between focus, f, and optical center. Recall magnification factor m is negative for real and inverted image. M is positive for virtual and erect image. Also, m equals 1 means image and object of same size. M greater than 1 means enlarged or magnified image. M less than 1 mean diminished image. Also recall convex lens is a converging lens. It forms real and inverted images except the last case when object is between focus and optical center. Image with magnification -1 means that negative sign indicates image is real and inverted, and m=1 indicates the size of image is same as that of the object. Therefore, object is at 2f, and the image is also at 2f on the other side of the lens. Therefore, distance between the object and its image is 4f = 60 cm = f = 15 cm. Let's continue with the next part of the question. If the object is moved 20 centimeters towards the lens, where would the image be formed? State reason and also draw a ray diagram in support of your answer. Object distance to f equals 30 centimeters. If the object is shifted towards the lens by 20 centimeters, the new object distance equals 30 centimeters to 20 centimeters equals 10 centimeters. As can be observed, the new object, 10 centimeters, its distance is less than the focal length, 15 centimeters, and the image formed in this case would be virtual, erect, and will form on the same side as the object. Now let's draw the image diagram as shown here. Observe the image formed. Question 3. The linear magnification produced by a spherical mirror is +1/3. Analyzing this value, state the I, type of mirror, and 2, position of the object with respect to the pole of the mirror. Draw any diagram to justify your answer. Recall, M is positive indicates an erect and virtual image, and M less than 1, M=1/3, indicates diminished image. I, a magnification of +1/3 indicates an erect and diminished image. Only a convex mirror produces such an image. Because concave mirror also formed erect and virtual image when object is between focus, F, and pole, P. However, it forms an enlarged image. Recall the virtual image formation cases. 1. In convex mirror, always form diminished virtual and erect image. 2. Concave mirror, although converging mirror forms real image, but when object is between focus and pole form enlarged virtual image. Continuing with question 3, second part. 2. Position of the object with respect to the pole of the mirror. Draw any diagram to justify your answer. Position of object between infinity and the pole. The diagram below shows that for any position of the object between infinity and P, the convex mirror always forms an erect and diminished image. Question number 4. AB and CD, two spherical mirrors from parts of a hollow spherical ball with its center at O as shown in the diagram. If arc AB equals 12 arc CD, what is the ratio of their focal lengths? State which of the two mirrors will always form virtual image of an object placed in front of it, and why. Focal length of a mirror is given by focal length equals radius of curvature by 2. Since both the mirrors have same radius of curvature, therefore focal length of the two mirrors will be same, i.e. f1 upon f2 equals 1 is to 1. Since virtual image is always formed by convex mirror, the mirror AB will always form virtual image. Thank you for watching the video. Don't forget to subscribe my channel, Paradise Coaching. Please do like, share, and subscribe. Also visit my blog. Thank you once again for watching the video. For details, please visit my blog.